Okay, let's try to answer this question. An athlete can run 180 meters in 20 seconds. What is her speed? So, this one involves kinematic equation in horizontal direction. So, here, let's have now the given. The given is we have the given distance, which is 180 meters. And we also have the given time, which is 20 seconds. So we're looking for the speed. So the equation for the speed is simply v is equal to distance over time. So we have substitute 180 meter divided by 20 seconds. We have 180 divided by 20 is 9 meter per second. So this is now the speed of the athlete. Okay, how about this problem? Let's have another problem. So let's write the given once again. But first, before you write the given, the kindly read the question first. A child rolls a ball onto the floor and it starts moving at 12.8 meter per seconds, but stop rolling after 6.3 seconds. What is the ball's acceleration? So we're looking for acceleration. But before we compute for acceleration, let's begin with the given. So the first given here is this one. It start moving at 12.8 meter per second. So we have a given initial velocity, which is 12.8 meter per second. And then it says here, but stop rolling. So meaning to say, when you stop, your velocity was already zero. So the final velocity is 0 meter per second after 6.3 seconds. So we have time given 6.3 seconds. And we're looking for the acceleration. So, were you able to remember what is the acceleration equation? We have acceleration is equal to change in b over change in t. So, if we expand change in b, we have final velocity minus initial velocity over change in time. Final time minus initial time. So, we have here 0 meter per seconds, the final velocity minus 12.8 meter per seconds, the initial velocity. And the total time is 6.3 seconds. Let's compute. So we have here 0 minus 12.8 is negative 12.8 divided by 6.3 seconds. So let's divide 12.8 divided by 6.3 is equal to 2.03. But since it's negative, so we have here, okay, this is not the answer. We have equals negative 2.03 meter per second square. So this is now the acceleration of the ball. Now, you may be asking why it's negative, because base here from 12.8 meter per second, it stopped. Meaning to say, the ball is decelerating. So when we have deceleration, then the sign representing by deceleration is negative sign. Because meaning to say, suddenly the ball is moving slow until it stops. So it's negative sign. So we have negative 2.0 meter per second square. So that is the answer. Okay, let's try to answer this. What can you infer about the situation? As you can see, we have here a car, or let's say this yellow one represent the car. So this is a car. So this is the motion of the car. Now, on the choices, it says is it a constant velocity, constant acceleration, zero velocity, and zero acceleration? In order to identify the correct answer here, we need to identify first the given. So we have here a given distance of the car travel, and the time. So in order to have that, let's write it in a table. So we have here a given distance and a given time. Okay. So we have here 0 meter, 0 seconds. 5 meter, 1 second. 20 meter, 2 seconds. 45 meter, we have 3 seconds. Then 80 meter, 4 seconds. Since the one being asked here is whether it's constant velocity, constant acceleration, zero velocity, or zero acceleration. So let's try to compute for its velocity and acceleration. So let's create another table here. Let's compute for the velocity first. So 0. So remember the formula or the equation to get the velocity is distance times time. So let's just simply divide distance over time. So here, 0 divided by 0 is 0. So it's 0 already. How about this? 5 meter divided by 1 second, we have 5 meters per second. How about this? 20 meter divided by 2 seconds, we have 10 meter per seconds. How about next one? 45 divided by 3, we have 15 meter per seconds. How about the next one? 80 meter divided by 4 seconds, we have 20 meter per seconds. Now, what can you see here in the computations that we have? The value of velocity. Is the velocity changing? Yes. As you can see, from 0, it became 5. After 2 seconds, it became 10. After 3 seconds, it became 15. And then when it when we have 4 seconds, it became 20. So as you can see, the velocity is changing. And if the velocity is changing, therefore, we can say that the velocity is not constant. So letter A is not the correct answer. How about letter C? Do we have zero velocity? No, because the velocity have a value. So we have 0, 5, 10, 15, 20. So letter C is not the correct answer as well. So we are now solving whether B or letter D is the correct answer. So how are we going to solve for the acceleration? Let's try to find the acceleration to find out whether we have a constant acceleration or a zero acceleration. So what is the equation for acceleration? Velocity over the time. So we have here velocity divided by time, 0. 5 divided by 1, we have 5 meter per second square. 10 meter per second divided by 2 seconds, 5 meter per second square. 15 meter per seconds divided by 3 seconds, we have 5 meter per second square. And then 20 divided by 4, we have 5 meter per second square. As you can see, when the car starts moving, it has now a constant acceleration, which is 5 meter per second square. So therefore, the answer here is letter, the answer here is letter B. We have a constant acceleration. When we say constant, the magnitude is not changing. It's the same all throughout the time period. So we have letter B. So that is the answer. Okay. How about the continuation of the question? What is the average velocity after 4 seconds? So let's try to draw first the car. Okay, we have here the car. This is the car at 1 second. This is the car at 2 seconds, the car at 3 seconds, and the car at 4 seconds. So let's compute for the average velocity. So we have here the average velocity is equal to 80. We have here the distance cover, which is 80 meter, divided by the total time cover, which is 4 seconds. So we have here 80 meter divided by 4 seconds. We have 80 divided by 4. We have, the average velocity is 20 meter per second. So that is the average velocity. Let's try to answer this question. A car running along a straight line increases its speed uniformly from 50 meters per second to 70 meters per second over a time interval of 2 minutes. What is the acceleration of the car during this time interval? So, let's solve for the acceleration by identifying the given. So, we have here the given. A car along a straight line increases its speed from, so the velocity initial or the initial velocity is 50 meter per second to 70. So this is not the final or the value of the final velocity is 70 meter per second over a time interval of 2 minutes. So we have a given time which is 2 minutes. Now let's convert 2 minutes into seconds. So we have 60, 1 minute. So we have 120 seconds. Now, let's compute for the acceleration. So the equation that we're about to use is acceleration is equal to change in t over a period of time. So we have here a final velocity minus initial velocity over the time, which is 120 seconds. So we have 70 meter per seconds minus 50 meter per seconds equals 120 seconds. 70 minus 50 is 20 meter per seconds divided by 120 seconds. We have 20 divided by 120 is 0.17 meter per second square. Now, as you can see here, it's positive because the car is accelerating. As you can see, from 50, it became 70 meter per second. So we have a valid answer, which is 0.17 meter per second square.